Hey everybody, hope you're doing well. This video is going to walk you through how to factor expressions completely. This is the start of week 6, and this week here we're going to finally wrap up everything here in Unit 9 dealing with polynomials and factoring. This lesson and the one after it are going to deal with what we call factoring completely, where we're going to use all the factoring strategies in a blender, if you will, rather than doing them in isolation. This video will look at how to factor, and then the final lesson in the next video, we'll do factoring and solving at the same time. So let's take a look here at this little graphic I've got filled in, how to factor things completely. So you've learned 4 factoring strategies. You've learned how to factor out a GCF. You've learned how to factor trinomials apart using trial and error. You've learned how to factor binomials using difference of squares. And you've learned how to factor quadrinomials by grouping. What we're going to do now is, instead of me giving you a specific strategy, we're just going to work through problems where I'm just going to say factor. And what you're going to have to do is figure out what strategy or strategies you can use to break expressions apart. Everything you've basically done so far only used one strategy. There are many expressions that use more than one strategy to break the problem down. So what we're going to take a look at here first is review the strategies and figure out what order we try to break these apart in. So you can see the flow chart up at the top. You can see the top of the flow chart says find the GCF. Anytime you try to factor, the first thing you want to look for is seeing if you can take out a greatest common factor. Can you take out a GCF? Some problems you will, some problems you won't. But either way, that is the first thing you're going to look for. So for each of the problems I'm going to go through in this video, that's the first question I'm going to ask. Is there a GCF? If there is, take it out. If not, that's fine. Whether or not there's a GCF, then we look at, well, how many terms do we have? 2 terms, we're going to see if we can break it apart using the difference of squares pattern. You can see an example of that listed in the box on the left. If we have 3 terms, that's our trinomial. Multiply to C, add to B, and you can see an example of that listed in the box in the middle. If there's 4 terms, we will break things apart using the grouping strategy, and again, you can see a box listed there. So basically what we're looking for in these problems, can we pull out a GCF? Cool if we can, cool if we can't. And then look at how many terms we have in the problem to see what strategy we could possibly use. So several different examples here. I would highly suggest, if you copy down anything or have anything as a resource, I would screenshot this or jot this down somewhere, so when you're working on the graded assignment for this, you have this little chart handy and you know what order you need to do things in, because this will definitely help you out. So let's go ahead and talk through some of these problems. So again, I'm not telling you what strategy or strategies to use. I'm just now saying go factor. So number 1 here, the first thing we're going to look for is, can I take out a GCF? So remember, greatest common factor is what can I divide out of all the terms, not just some of them. What can I divide out of all of them? And I want to make sure, this is going to be very important, that we take out the biggest thing possible. Some of these problems will have smaller common factors that you can take out, but if you take out something that's too small, it's going to be a lot harder to factor things correctly. So we want to make sure we take the greatest thing out if we can. In number 1, the greatest thing I can take out of all 3 terms is a 4. So the first thing I can do here, and I'm going to label what strategy I use as I go through, is I can take out a GCF. So I can take out a 4, divide that away from the 3 terms. I'd have x squared minus 11x plus 24. So remember, when we factor a GCF, write the GCF out front. In parentheses, we list what's left over when we divide out the GCF. Now, I'm going to look at what's in those parentheses. I see a 3-termed expression, x squared minus 11x plus 24. 3 terms means if it's going to factor apart, it's that trial and error, multiply to C, add to B strategy. So remember, C is that constant at the end, B is the value that's stuck with the regular x. So what we want to try to do is, what multiplies to 24 and adds to negative 11? Well, what does that would be negative 3 and negative 8. So what I'm going to do as I move down to continue the factor is, I'm going to use that trial and error strategy, so I'm going to label that T and E. The 4 was already factored out, so I'm going to just drag that down with my work. I'm now going to split apart the trinomial into x minus 3 x minus 8. Typically speaking, once you break it down, so it's just x's. You don't have x squared or x cubes or anything like that. Once you are down to this, you are finished. Because you'll look at the factors that we have left, we only have binomials. They don't meet difference of squares, so there's nothing more I can break apart, and that will be finished. What we're going to look at in these problems is typically, if they're going to require multiple steps, it'll be 2 layers of factoring. There's really not any problems that you're going to encounter that will be more than that, at least at this level. Okay, so again, we start with finding a GCF. There was one, we took it out. We had 3 terms. We then used trial and error. Second problem here is going to be pretty similar to it. So I have 3x cubed minus 21x squared plus 30x. First thing I'm going to do, is there a GCF? Yes, there is. So again, I'm just labeling what strategy I'm using. I can take a 3 and an x out of all 3 terms. So out front comes a 3x. What's going to be left over? I'm going to divide 3x away from each of the terms. I'll have x squared minus 7x plus 10. So I take out my GCF, I look at the leftovers there in the parentheses, I see 3 terms. So once again, that's your trinomial, your trial and error strategy. So we want to see what multiplies to C adds to B. What multiplies to 10 adds to negative 7. Well, in this case, I can break that down by multiplying negative 5 and negative 2 together. If I add those up, I get the B value as well. So I'm going to pull down the GCF. And again, I'm breaking apart the trinomial. What multiplies again to 10 adds to negative 7, negative 5, and negative 2. My final answer would be 3x times x minus 5 times x minus 2. So again, very similar to number 1. I took out the GCF, looked at that first, then took a look at the trinomial that was there, and broke it apart. Always make sure, a common mistake when you have to do multiple layers of factoring is leaving factors behind. Make sure if you take out a GCF or do anything else, make sure it comes down with the rest of your problems so that you have all the factors that you're supposed to. So we're going to continue with this again. As I move the slide here, this chart's going to go away. I would probably, again, jot this down just so you have it handy as we go through. So let's go ahead and look at the next handful of problems here. So number 3, same deal. First thing I want to see is there a GCF? And once again, there is. So for GCF, if I look at this problem here, I can take out a negative 2x. The reason I take the negative out is because something that that I mentioned back when we did GCFs, and I know that's going back a couple of weeks here. If what's out in front is a negative, you want to make sure to take the negative sign with it because it'll allow your factoring strategies to work a little bit better. So I'm going to take out a negative 2x and divide it away from all the terms. That'll leave me with a positive x squared, a negative 3x, and a negative 54. Now I look at once again, I have a trinomial that's left over. What multiplies to negative 54 adds to negative 3? Well, in this case, that would be negative 9 and positive 6. So I bring down my GCF, I split apart the trinomial, get a final answer of negative 2x times x minus 9 times x plus 6. All right, now we'll take a look here at things that aren't trinomials here. So that should give you some good examples there, 1 through 3 of, hey, GCF. Then we have a trinomial break apart, some good examples there. Let's go ahead and take a look at number 4. 4, we only have 2 terms, so there's a good chance here that we're going to have to do some difference of squares action. But again, first thing I want to look for, is there a GCF? And once again, yes, there is. You notice that'll be a pretty common theme in these problems. Now again, that doesn't always mean there's a GCF to take out, but typically speaking, if we're doing multiple layers of factoring, there's probably a GCF involved. So, again, I want to take the most out that I can. I can divide the 3 out from both numbers, and I can take out x to the 4th out of both terms. So when I divide 3x to the 4th away, I'm left with an x squared minus 25. So now, what I have left over is only 2 terms, so that means I have to look at, can I do difference of squares? So difference of squares, remember, it's very specific. has to be subtractable, and it has to be two perfect squares, aka they can be square rooted with ease. X squared and 25 can be easily square rooted, so we can use difference of squares in this case. So I'm going to abbreviate that as DOS. Bring down to 3x to the fourth. X squared minus 25 using the difference of squares pattern. X plus 5, x minus 5. You take the square root of each term. They look pretty much the same. One gets an addition sign, one gets a subtraction sign. Once I've done that, I am factored as far as I can. Final answer would be 3x to the fourth times x plus 5 times x minus 5. 5 and 6 you'll see will be kind of the same. So again, if you want to give that a try here, hit that pause button and see if you can figure some stuff out. Feel free. Otherwise, here we go with the explanation. So again, number 5, I have a GCF. I can take a 5 out of both terms. Okay, there's not a variable in both, so I can't take any variables out, just the 5. So if I divide that away, first term would be x squared. Divide away from the second term, I have minus 4. I have another binomial in the parentheses. Again, only way that can break apart is if it follows difference of squares. Are they subtracted? Yes. Are they both square rootable? Absolutely. So I can use difference of squares. Pull down to 5. X squared minus 4, if I break that apart, square root each piece, I'd have x plus 2 and x minus 2. So my final answer, 5 times x plus 2 times x minus 2. And last but not least, for these type of problems here, number 6, we got ourselves GCF. Again, so we have negative 45x squared, 20y squared. The biggest thing I can take out is a negative 5. Again, my leading coefficient is negative, so make sure to take the negative sign with it. You can't take a variable out because there are two different variables, so don't try to take an x or y out because they're not the same in both terms. So just the negative 5 is all you can take out. When you divide each by negative 5, you're left with 9x squared minus 4y squared. So again, binomial, difference of squares, they are being subtracted. Both terms can be easily square rooted. So 9x squared would be 3x, square root of 4y squared would be 2y. One would get added, and one would get subtracted. So your final answer, negative 5 times 3x plus 2y times 3x minus 2y. So again, you see some examples there, multi-layered factoring, taking out GCF and having a binomial left over using the difference of squares pattern. Looks like we've got one more of those here in number 7, so I'll run through that real quick. If you want to try that again on your own, please feel free. So once again, I can take out the GCF. Biggest thing I can take out is a 3x squared. Divide that out, I'm left with 4x squared minus 25. That binomial that's left over, that meets difference of squares because it's being subtracted. Both terms I can easily square root. 4x squared is 2x and 2x, 25 is 5 and 5. So my final answer will be 3x squared times 2x plus 5 times 2x minus 5. So now, last but not least, we've got some factoring here that we're going to do with 4 terms. So this is the newest strategy you've recently learned, which is how to factor by grouping. Now, typically when we have quadrinomials here, when we have these 4-term expressions, typically you won't have a GCF to take out. Just generally, the more terms you have, the harder it is to find a GCF. It doesn't mean that it can't happen. We're still going to check for that first, but oftentimes with these problems, that's not where you're going to start. But you'll see how we have multiple layers of factoring here in a minute. So number 8, first thing we're going to check for is a GCF. If I look at all 4 terms, I can't take any GCF out because A, they don't all have numeric coefficients because you got that invisible 1 out front that makes it really hard to find a GCF there. And B, you don't have variables with all 4 terms. So there is no GCF. So we're going to skip that and go right to the fact that it's a 4-term problem. 4 terms means we do grouping. So if you recall the grouping strategy, that's when you take the problem, split it into 2 halves, put parentheses around each half. You find the GCF of each half. So I am, again, using the grouping strategy. So you're still kind of finding GCFs, but again, it's not the standard way that you would with some of the other problems that we just did. But again, grouping strategy, we're going to find the GCF of each group and break it apart from there. So x cubed plus 4x squared. I can take out an x squared and be left with x plus 4. Then I can take out a negative 25 in the second group and be left with x plus 4. Remember, in the grouping strategy, if you do it correctly, those pieces in parentheses should match exactly. And again, you can see here that they do. That tells me that so far, so good. Your factors then, when we rewrite this and reorganize it, x squared minus 25, so what we pulled out, that makes up a factor, and what's in common makes up the other factor. Now, if you recall from the last video, there were a couple problems where I mentioned when we did the grouping strategy that there was, quote, more to do. This is now where we're going to emphasize the more to do part, because now we're going to factor this as far as we humanly can. So you notice the two factors that we have. We have x squared minus 25 and x plus 4. I'm going to focus on the x squared minus 25 because that factor right there, that binomial, meets difference of squares. You've got two square rootable terms being subtracted. So that means I can go one step further. I can break apart x squared minus 25 into x plus 5, x minus 5. The x plus 4, though I can't do anything with it, it's still part of my problem, so I drag it down. And now I can get my final answer. X plus 5 times x minus 5 times x plus 4. A typical problem with 4 terms, if it's going to have multiple layers of factoring, that's typically what it's going to look like. You'll group it apart first. You might have a factor that you can do difference of squares with. Sometimes you'll have that, sometimes you won't. Again, it just depends on the factors that you get. So 9 and 10, similar examples here. We'll go through these here and see how far, again, we can get. So 9, there is no GCF. They don't all have coefficients that are above 1, and they don't all have variables. So I'm going to go right ahead and group. So in the first group, I can take out an x squared and be left with x plus 5. The second group, I can take out a negative 4 and be left with x plus 5. I know I did it right because I have some matching pieces, which means I'm in good shape. I can rewrite this as x squared minus 4 and x plus 5. Now I'm going to take a look here at my factors. X plus 5 I can't do anything with. X squared minus 4, that again meets difference of squares because they're both square rootable terms and they're being subtracted. So I can take this and break it apart as x plus 2, x minus 2. I drag down the x plus 5 because that's part of my original problem. And I get my final answer. X plus 2 times x minus 2 times x plus 5. Alright, last example we have here looks like number 10. 8x cubed plus 12x squared minus 18x minus 27. So, GCF here, if we take a quick look at this problem, they do all have coefficients above 1, but we'll save some time here. There is no GCF. It looks like you could try to divide something out of everything here, but you can't. So they don't all divide by 2, they don't all divide by 3, which would probably be your common go-tos, but you can keep testing numbers. It's not going to have a GCF. They don't all have variables either, so we're just going to go ahead and go straight to grouping. So once again, here's my parentheses. So the first group, I can take out a 4x squared and be left with a 2x plus 3. The second group, I can take out a negative 9 and be left with 2x plus 3. Again, I know I did it right because I have matching pieces, which means my two factors are the 4x squared minus 9 that I took out and the 2x plus 3 I have in common. Once again, I'm going to be able to use difference of squares. If I look at the 4x squared minus 9 factor being subtracted, and both can be square rooted. So I can take 4x squared minus 9, turn it into 2x plus 3, 2x minus 3. I pull down the 2x plus 3 that was in the last step, because even though we see that it repeats, it's still part of my answer. This is an acceptable way to write your answer. If you want to get a little fancier, since you have two of the 2x plus 3 factors, you can also write it like this, or you could say 2x minus 3 times 2x plus 3 squared. Since we know if we square something, that just means it's being multiplied by itself. Again, I don't really care which way that you write it. It's not the end of the world. But that's technically, if you wanted to shorten it up, that second way is the way you could write it as well. So, you can see there, it's tedious, but again, it's using all the strategies you've learned, but again, ultimately it's about recognizing when you can use which strategy. So the focus on this is going to be working through problems that have multiple layers of factoring. That flow chart will hopefully help you to figure out, as you're doing this, which strategies to use when. You're always, again, starting by finding a GCF if you can, and then moving on to determining how many terms that you have and what strategy you will use from there. So, with that being said, you've got your graded assignment that goes with this here. I would highly suggest that you take your time with it and making sure that you go back to this video here. Because again, the ones that you'll get are going to be very similar to these examples that I kind of just ran through here. So definitely take your time with it. Try to avoid all the goofy mistakes with signs and things like that. If you need some extra help or have any questions, send me a message on Schoology. Shoot me an email. Stop by my office hours on Zoom. Because I know there's definitely more to this. And again, since this has been newer all marking period here, you definitely want to make sure that you understand this. There's a lot of this stuff that you're going to see next year as you move into Algebra 2. So you definitely want to make sure that you're practicing this and that you're trying these on your own. So work through this. You got your graded assignment here. Again, we're going to wrap up Unit 9 in the next video where we're going to take these and use a zero product property with it as well and actually solve for X. So if you, again, need anything, please don't hesitate to get a hold of me. Otherwise, thanks for watching. Stay safe, stay healthy, and we will see you next time.